this is Arnaud, Koin project lead. I would like today to talk about dependency injection inside Compose application. First, let's talk about Compose. Compose is the new Android UI toolkit made by the Google team that proposed a new declarative UI approach for the Android development made on Kotlin API. For you, then you use Kotlin function to declare all your UI. This implies that this is less UI plumbing for you, and this is compatible with your existing Android application. Behind that, you have to consider that this is a new paradigm because we are talking about declarative UI approach. That means that you have to consider your UI has to react to event and state. You receive data and then your UI is reacting to new events. This pattern is also known as a unidirectional data flow pattern, where actions are triggered on view that can then generate new state that help generate new views. Then in this video, we'll see what's impact in terms of application architecture and dependency injection. Before getting into Compose dependency injection, let's get back with the Android architecture. The good news is then to make some Compose application, you already know most of the parts. You know how an Android application lifecycle is running, then you already know most of the integration of the components. Then to wire your Android fragments, activity, view model, etc., you already know that everything is following its own lifecycle behind the UI, and then we are plugging components like repository, data sources as a singletons into our applications. To set up those components into Koin, we need a few configurations. That means that those repository data sources components are classically declared as singleton in Koin with the single keyword. Presenter view model are factory or view model, and then all the Android UI are mainly used by the delegate property injection with the by inject. Note that fragment can be injected by constructor and soon activity. If you are using business rule or use case interactor class component, then you can describe them as factory or singleton in the way you like. The scope integration is done at the presentation layer behind the UI to help you really coordinate with a custom lifecycle around your screens. Finally, how do we work with Compose as its functions, and then what do we use in terms of API? And how we use, integrate, and what kind of instance do you integrate behind Compose? Then how do we work with Compose and think about dependency injection? Finally, is Compose just a function? Do I need to make a functional programming then? Or do I need to learn a new lifecycle for that? The key things to understand behind Compose is recomposition concept. That means that recomposition is recomputing depending on your inputs change. And then it's triggered when your states of your inputs are changing. Finally, how do we think about dependency injection in Composable? Inside a function, we can imagine a few entry points. We can imagine our dependency as a function parameter with the default value, for example, and then we could use our API here. Also, we can use our component inside our body in function body. Then the question is, do we use parameter or value? It will depend how you want to extract your injection or make your widget depending of your injection. You can check the how state article on the Google documentation. That is a good example and will describe this for you. Let's now inject Koin inside a composable. Let's use Koin inside Compose. For this, you just need Koin Compose or Koin Compose Navigation if you are using view model navigation APIs. At the time of this video, Koin is in version 3.5.3. To inject inside a composable, you can use directly access to Koin with CoinPlatform.getCoin that is accessing your current context of Koin, and then you can retrieve any dependencies. The thing is, it will trigger a recomposition of your component because then this API is not Compose compatible directly. You can use the Koin Inject API to retrieve your dependency, and it will stick to the current recomposition of your widget. You don't have to retrieve anything else, just use the Koin inject, and even a factory instance will stick to the current instance of your widget. Because then it's cached in Compose. And then it will be recreated if your composable is dropped and then recreated. You can use Koin inject inside your function as a default value parameter. That means that you can pass any parameter to your function if you want the default value to use Koin, or in test or any custom case, you can pass any parameter here. How you can trigger a composing injection? You can do that by triggering parameters inside the injection. That means, for example, here we are passing the clicks as a parameter of our factory, and this component is then injected inside the constructor of my factory. You can see on the samples below that it's triggering recomposition. About view model, how you can do that? You can just use Koin view model function to retrieve your view model. It will inject your view model. Be aware that it's not a lazy expression, contrary to the by view model Koin expression or delegate. Here is directly a function that is retrieving your view model instance. You can use it in the body also. And here you see that it will also be held in cache, but in the view model cache, not the compose cache. If you are using navigation features, use the Koin nav view model function. If we go back to our big picture as architecture, we keep the same layers of architecture and software with the repository data sources and database with singletons. Our presentation layer is still declared as factory and view model. And finally, our Compose UI widgets are triggered with the Koin Compose API. One of the questions you may ask is, do we use view model or not? Because finally, we can stick with factory instance directly to our view model widget. You can think as a stateholder has a factory instance if you want a component stateholder, or if you think about screen level state, then you can think about view model. This view model will be a more global component that dispatch your component to your other widget. Let's dive into some more advanced API for Compose. There is a Koin application composable functions that you can use inside your function. Here, for example, is our composable function counter. We can use Koin application here to declare a Koin instance directly from this composable. The interest of that is that it's starting a Koin application from this point. That is interesting because you don't depend on, for example, the start Koin function that you can run from your main entry point. The other usage of such function is you can preview a composable from a custom module and then don't have to load your entire Koin hierarchy modules. The other aspect that you can use with composable is the dynamic module load of Koin. For example, in this composable, what we can use is remember Koin modules that finally will load and unload modules for a composable. That means that the first time the widget will be created, it will load the modules that you are describing here, and then when the composable is dropped, then it will unload the modules directly for you. Other case you can have is Koin scope in composable, where finally you can declare a dedicated Koin scope and then open custom scope dependencies from this area. One really great feature is the Koin context isolation in composable. It's super interesting for white labels and SDK application. For SDK or white label application, you usually have an isolated Koin context application. That means that you don't use directly the start Koin function. You have your own Koin configuration beside any kind of application. Then you have an isolated context that is run here by Koin application. It's just Koin application function with your configuration here, but it's not started in the main context. And then when you run a composable, you can use Koin isolated context with your own context, and your composable will run all your definitions from this isolated Koin context. You won't have any conflict with any existing definition from an application that is using your SDK using Compose. Let's end this video talking about with Compose Multiplatform. Compose Multiplatform has been announced last year in 2023 at Koin Conf, and it's covering all your capacity to describe UI in Compose for Android and iOS and more. And the good thing is Koin is ready for Compose Multiplatform. Check about Koin Compose module in version 1.1.2 that is already multi-platform, and then you can build from iOS application to desktop and any other Compose compatible application. You can use any multi-platform API that we are already seeing together, like Get Koin, Koin Inject, Koin Application, Koin Context, Koin Isolated Context, Remember Koin Modules, and Koin Scope in your application. About multi-platform with Koin, we can share with you some injection best practices and how you can use Koin with a multi-platform, and all of this is summed up in a Koin Kotlin multi-platform cheat sheet. You have this URL in the description of the video. I hope you enjoyed the video. See you next time. Salut! And don't forget to go on insertcoin.io, the Koin framework website for the project, where you get the latest news and all the documentation related to the project.